Okay, hello guys. Today our topic is about the geometric and measurement too. Okay, so let's move into the first part about the symmetry. Okay, so what is symmetry? Okay, so you can find in here we have two graphs. Okay, so we called they're both in two-dimensional line symmetry. Okay, so for rectangle you can say that there are two symmetrical line. Okay, maybe here this is the first line. Okay, and if you're trying to fold maybe the rectangle along this symmetrical line, you can find they can just cover with each other or with each other side completely. Okay. So we can say when you're just folding it, they can cover with each other or with each side completely. That is a symmetry. Okay. So also you can find this is also a symmetrical line, right? And every part you can find this part, you can find I draw a blue rectangle, and for another part I draw a purple rectangle. They're the same to each other. Okay. Or we can also consider like here the lines is just like a mirror. Okay. So every part on the left side or right side, on the upper side and down side, they are the same. Okay. So also you can find the kite, we have only one symmetrical line, right? You can find the left part and the right part. They're just like a guy looking in the middle, right? They're the same with each other, right? And each part, they have the same distance to the mirror, okay? But if you want to trying to consider about if there is another symmetrical line here, like a blue line, I will tell you that this is not a symmetrical line, right? Because here you can find this point A and this point B, they have the different distance to the mirror, right? So we cannot say that they have a symmetrical line, okay? Or you can also say maybe here, triangle ACD is very different from triangle BCD. So this is not a symmetrical graph, okay? So that is for the line symmetry in two dimensions, okay? And also we have a rotational symmetry in two dimensions. Okay, you can find here on the left graph is a triangle. Okay, so you can find each time you just make a 120-degree turn, you can find the triangle still remains its shape, right? Okay, and you can find here is a parallelogram, and if you're just turning 180-degree, that is the same direction or the same graph with the original graph, right? Okay, so we can call this as a rotational symmetry. Okay, that is it. Or there's a very another classical example like here we draw a circle, right? And like if you turn like n degree, okay, or you can turn any degree here, you can find every times circle is a symmetrical graph, okay? So we can say that circle is also a very classical example in rotational symmetry, okay? That is very important. Okay, and after that, we're just talking about the regular polygons, okay? So polygons means that we have like n side in the graph, okay? So we can say maybe here we have a rectangle, okay? So we can say that is a polygon with four sides, okay? That is n equals to 4. You can find here this is a first side, second, third, and last, okay? Or also you can say square also is a polygon with n equals to 4. Okay, so you can find first side, second side, third side, and last side. Okay, so you can find here if you want to draw a hexagon. Okay, so hexagon like here, that is a hexagon. So one side, two side, three side, fourth, fifth, and sixth. Okay, that is a hexagon. Okay, so we can say hexagon always have n side right here. Okay, so we can also say here, not only for symmetrical in two-dimensional, we also have symmetry in three-dimension, okay? So we can say that it's a plane of symmetry. But remember, in the IGCSE, most of the times we are not using symmetry in three dimensions. There are very, very little problems asking you for three-dimensional symmetrical problem. Okay, so don't be worried about this, okay? So you can find here, as we just using a cuboid, okay, and we can say there are exactly three planes of symmetry, okay? Why is three planes of symmetry? Because here, this is the first plane, right? And the second plane is here, okay? That is the second plane. And we can say, and the third plane is this way, okay? So I draw a green color like here. So there are three planes for symmetry. Okay, you can also say that we have three symmetrical plane in the cuboid. Okay, and for cube because it's quietly very asymmetrical graph, so we can say it's a line planes. Okay, but you don't need to understand why a cube has a line planes right here. Okay, you don't need to understand for this. Okay, that is it. And also we have the symmetry in three dimension, and we can say there's axis of symmetry. Okay, you can find here that we have maybe here we have a cylinder, okay, and then we can say that is a central line. This is axis of symmetry, okay. So you can say that is like a cylinder, and every part of the graph it can rotate around the axis, okay. That is it. And also we have some deliberate practice for you, but I guess it's not very difficult, okay? So maybe after this class, you can try to do one by one, okay? So today, we will not leave you for time to understand for this. You can just try to take your time after the class, okay? So that's for today's lesson. See you next time. Bye.